And I'm live. That is pretty cool. Today is 17th of April 2026, Friday. And like for real, let's just uh, finish deploying this thing. Actually deploy this thing. Cool. So right now, here Docker Compose file is totally cool. We are able to build the services and we are able to run them. And there is a local database for running this locally. There is the backend, and then there is Nginx development, which serves the backend, which is acting as a reverse proxy to send things to backend, requests to backend, and also to serve the front end, the build of the front end. And then this also starts ty at a certain server and Postgres. And now the next problem is that the Postgres and Docker, this backend, they are not able to communicate. They should be able to communicate using networks. And this is just for local development when we want to run these things locally. So I guess after the build, we also networks. Yes, we can give networks, and network for this would be, let's say, SHA would be the name of the network. And I guess we define in Docker Compose separately here networks. Yep, networks, a list. SHA. Shit, no. Incorrect type. Expected object. Networks takes an object. Okay. How to define networks in Docker Compose? Networks front end. Okay, the name of the network. Okay. SHA, and this will have name. Yep, a name is a thing that this has. Name would be SHA, and outside would this be able to, I guess, external. Yes, external. Wait, external. How to deny external access to a network name, custom driver, IPM config, subway, using an external to true property. If you have a network, create it outside of Docker Compose. Okay, so this is not the one that we want. Deny. Wait, I guess, yeah. I thought maybe we can put backend and this Postgres thing inside a network and deny them access to the actual global network, the internet. But I guess it is fine as it is. Cool. So network SHA, and we will connect the TUI. Nope, nope, not the TUI. We need to give this TUI environment variable called backend API. When running locally, it would be HTTP. No HTTP, just backend or localhost 2222. But shit, incorrect type, expected string. Okay. Okay, and this is part of a network. We need to add this to the network, to networks star network. Okay, database URL, we are giving it to the backend, and Okay, here target nginx dev docker file. We need to change where the front end sends request dev. Here dev, this uses dev, and I guess we are at the right place for this development. Localhost 2222 for this is correct, and for the TUI, yep, we are manually taking in this thing. Okay, so how do we get environment variables? Hello, top chats, no, live chats. Your message went away somehow. How to get env variables in Go? How do we get environment variables in Go? Go by example. Shit. Okay, let's go. Go by example is pretty cool. Environment variables are a universal mechanism for conveying configuration information to Unix programs. Let's look at how to set, get, and list environment variables. Pretty cool. So os.get env. Cool. This os.get env here will say plus and instead of this plus os dot get env environment variable for backend URL. I think that should be cool. So when we run this Go program, we just have to give it an environment variable. Okay. Or run or build this thing. One of these things. I think when we are running this thing, then we should give it an environment variable. Localhost. No shit. When we are building this, then we are supposed to, because Go is compiled. So cool, makes sense. And we are building Go in the Docker file. Not this one. We can just delete this. For Go, this is the Docker file. Cool. So I guess in that case you will have two different builds for Go. Environment variables. Before Go build, we have to give in the environment variables to this container. Yes, this container needs environment variables. Run. But the environment variables are necessary at the build time for this container. So how to give variables to Docker build at build variables. Arg my variable, define the variable name, echo, run this, use it in command, and when we do Docker build arg build argument for my variable, it is equal to this. Okay, cool. We can just use this, and I guess here we should be able to say how to give environment variable in build. Environment variables, Docker build, chat, arg backend URL is an argument which you will take, and when we run this, we will say backend URL equals at the rate backend go build. Cool, makes total sense. And yep, backend URL. Cool. So this is needed at build time, and this is needed at build time. Cool, cool. I guess if we can have variables at the time of build, we don't even need two versions of this front end image, that is front end development and front end production image. We can just have a variable which decides what to do. Like, that is one possibility, but okay, we can look at it in a while, in a minute. Before that, let's see this. Now we are able to give, we should give an environment variable to go when we are building this Docker file in Docker compose here. Yep, and build args. Yes, cool. Args would be a key value pair. Backend URL underscore URL in this case is localhost to cool, key value pair. Cool. For the TUI, this is the backend URL. And we are also updating this cool Postgres. This is the place. Localhost. No. Here in this, which part? This first part is defining the protocol. This second part is defining the host. This is defining the this is defining the host. This is defining the username, the password, the host, the port. So host is not this. Host is this. Postgres. Why is Postgres the host? Because that is the name of the container here in the Postgres container, and the database is this. Okay. Docker image list. Shit, Docker not working, or the Docker engine is offline. Docker image list, Docker compose, build. Anything else? No, nothing else. Docker compose build, that should work, would allow access from other apps. Okay. Exporting layers. Okay, that okay, we have this build. Docker compose create, to create the containers. Docker compose create and start. Okay, and localhost 1234. I think that is the URL. Cool. Allow, and let's create an account. Walrus 123. Just Walrus is fine. Password. Okay, there is a problem. Why the backend URL is cool? Okay, internal server error. Localhost this. Okay, error was true and message is nothing. So the request went to the backend. Docker logs for backend server is listening, nothing. Let's open the Docker app so we may see. You can go to like execution part. Shit. Doc. Go to dashboard. Yes, cool. Containers running this backend container. Okay, we are inside the backend container. Apps backend and we would like to make some changes. The server is running in this. I think we can see ipconfig. Okay, ipconfig is not there. If config, oh, I don't know what that even does. Let's make a little change in the backend so that we get some logs. Index type declare, cannot find type declarations. One, install filter all, that is install for everything, and now we should not be getting those errors. We are not getting those errors. So APIs access, we made a request to /user/me, which is at access. No. Yep, /user/me. We got this error true. User info /user/me. So we never returned to this place. Something else exited before we could get here. And okay, and it was this. This plugin exited before we got here, and we got, is it returning something? Throw new error header is absent. Nope. But even before this we are running the error plugin. Okay, fine. Return user. Okay, let's see how far we are able to get in this. Console.log request received and headers present, got token. Okay, let's see. And if we get out of this, we would go here, console.log got to /users/me, and docker build docker compose build just backend, build just the backend. Okay, docker compose stop. I think docker compose is stop backend. So backend down backend resources is still in use. Okay, so we can, okay, shit, cool. Backend not working. Yes, a docker compose create backend, docker compose start backend. Okay, docker, yes, backend is working. And if we refresh, okay, internal server error, docker logs for the backend. Okay, request received, got token. Okay, we went too far, got token, but then after that nothing. Apps backend APIs user info, we didn't get to this thing, but we got token. Wait, why did we get token? We do, I think, yes, we do have a token, but the token is not right. But In any case, we shouldn't be getting 500 error here. 500 is crazy. Internal server error is crazy. We got token, and we did this, and I guess we were getting error here. Res wait, this user equals to this if token does exist, and await verify, we are calling this. Here we are verifying this token, which is not verifiable because the database is very new, so nothing is here. Testing token, correct token, cool. Okay, verify GWT. Swapping language with command tailwind CSS failed. The language server is either not installed. Okay, tailwind language server is not installed. That is fine. This dot public key. Do we have something inside the public key? Console.log this dot public key and console.log this dot private key. Console.log keys here. Docker compose or docker kill backend, docker remove backend, docker compose build backend, docker compose create for backend, docker compose start backend. Okay, backend is has started. Docker logs for backend, and okay, we do have the keys and everything. Keys are here. We were testing the keys and wrong. Okay, cool. That is like expected behavior. That is what we wanted. If the front end does not have the key or is sending the wrong key, then error. But internal server error is something that is not very good. Yeah. Throw error, and every throw error, I guess does not stop the server because it is handled by this thing, and this is what is sent back. Error. Something broke. Shit. Stopping container, removing container. Docker compose, build again the back end, create the container, backend, compose, start, backend, start backend, and refresh, and this time the error message, this thing me response, something broke. Yep, something broke. This is what we got, and we got internal server error. We should not be getting internal server error for a mistake made by the front end. try catch. Either we could have try catch all over the place, or we could just still continue to use this error plugin that we are using. Okay, let's see. What does Claude say? In a backend written in Elysia JS, the errors could be handled by something like this. Or wait, shit, we are saying that the status code is 400, but the status code which is reaching the front end is 500. Yes, so something is wrong with the status code. Status. How do I change the status code? Yep, that is the query. Not this. Here, how front end is status code 500, even though it should be 400. The issue is that we are calling status 400, but the error handler itself is throwing, because status isn't a function in the on error context. It is a setter, not a callable in the same way. In Elysia on error, you set the status code by returning a response set.status. But I guess, okay, set is a field. Set.status does not work, cannot invoke an object which is possibly undefined. Error and set.status 400 if it does exist. Okay, we have, this is not a function, like a callable function. Okay. Now let's see, docker down back compose down backend build backend docker compose create backend compose start backend, and now we should not be getting, at least we are still getting 500 internal server error. Because we are setting the error to 500. Okay, set docker compose down backy is not a thing. Backend docker compose build backend compose create backend compose start backend. Okay, and 400. Cool. Bad request. Cool. And now about the login folders. We got error, bad request, so everything is throwing error internally. Why? For creating an account, we are hitting this endpoint. Are we getting to this endpoint? creating a new user, but before this prefix, okay, there is no authentication test here, so something in this is throwing, and that I guess is this database part. This database is throwing, could be throwing error, or Zord could be throwing error. Safe, but no, we are doing safe parts, so no error thrown there. And cool. Zord verified, Docker compose build, or wait, tmux. Yes, should be working in tmux. Docker compose down backend, Docker compose build backend, Docker compose create backend, compose start backend. Again error, Docker logs for the backend. These are the logs. And the endpoint that we are hitting is slash. Okay, why are we still hitting slash user slash me after we create an account? Login. Slash login. Okay. Why is the request going to me? Shit. Request is going to the wrong place. Request should not be going to me. First of all, this again. Remove this, and from this here, remove the keys. We do have the keys, so don't worry. Or maybe just have these console.logs here. When we are creating an account, we are not hitting the right API. We should be hitting this. Hit slash user slash create, but we are hitting slash user slash me. No con. Is there something wrong with the front end? There should not be. There is nothing wrong with the front end. Okay, if we remove all the requests, and let's see where this one goes. An error occurred. Logs for the backend, Docker compose down backend, compose build backend, and how to create and start docker compose in one command. It is a single command docker which creates and is up docker compose up backend. Cool. And we should see say like in detached mode. Do not run this like this. Okay, we got a request, testing token was wrong, and then walrus 1 login, bad request there, but access create new user. We do not see create new user. So are we not sending the request this way? Access token or share. It could be access token. This thing is exporting access, which we are importing in this APIs thing folder. And yes, we are creating a no auth path which uses access Alicia, and then there are paths which need authorization, which are here, and then we are putting the no authorization path, then the authorization path, and then the anonymous path, which does not need anything. Anonymous game runner. These plugins have more scope than they should be, even though we have defined this one as scope. Anonymous path, this one is also scoped. This does not do shit. This one is also scoped. Okay, let's see the front end where we are actually sending the request. But yeah, we are sending the request at the right place. Pages, login, here, login form. Take input everything, and in this button on click we are calling this login user function with form values, username and password. In this function calls http base URL user / login console.log send request to backend docker compose down backend docker compose build backend, and exporting layers to image. Something went wrong. Docker compose build backend. Cool. Docker compose up backend. Okay. We do not see sending a request to backend, and also this is the old backend image where we were printing the keys. We are not printing. No, that is fine. That is fine. Those are older logs. Probably the error is that these plugins have more, say, yep, these plugins have more scope than they should, which is wrong. So let's see how to scope Eligio plugins. Local, which is the default, only applies to the route defined in the same instance and not propagated, encapsulated, fully isolated, nothing leaks or out global. And we are using like scope, local, global or encapsulated. We are saying scope, stricter siblings and parent. Yep, should not go to the parent, and affects siblings. No, only we want the plugin to only affect the children, the child. Like here, north and paths which taken the headers, which use token in the headers, and then anonymous. Okay. I want to put, if I have an Elysia instance which has some functionality, and then using it as an argument for the dot use of some other plugin, I want the first local, global. No, we don't, we need global. Global would be a bit too much. Dot use as global. You can also override scopes at the use call. Okay, this global only affects this plugin's routes, only affects. Okay, does not run here, does not run here, does not run here. Okay, cool. If we could how to copy a plugin with all its state. definitions. How do we copy a plugin? Hello, Jeet Patel 654 dot clone. Okay, shit. Base dot clone. Okay, we can use this. The main use case is reusing a base plugin definition across my shit. Yes, this is what we need. This is what we actually need. Okay, before making any changes to this, let's commit git add docker file and docker compose and apps slash tui. And what was the change that we made in users? Shit. Git add docker file, git status, nothing is added. Git add changes not staged for commit. Git add docker file, git status, git add everything, git status. Okay, now everything is good. Git target 0, git status. Okay, cool. Let's just make the change. Okay, not new. Nope, we will not use a new thing. No, we will not even use we will here say auth header plugin dot wait, there is no dot clone method. AliciaJS.com. Clone WebSocket clone an Alicia instance. Plugin. A plugin is a part that is recoupled from the main instance. Every Alicia instance can run independently or be used as part of another instance. We define plugin as this: decorate. We define something plugin. Takes in plugin and returns plugin. Alicia.use. But no, we want to create a clone of Alicia object. But clone does not exist. Decorate, resolve, we have everything except clone. as scoped. Compile. To be modular and lightweight, following the same idea as Arch Linux. I use Arch, by the way. And this is to ensure developers end up with a performant web server they intended to create. By extension, Elysia includes pre-built common patterns, plugins for convenient developer usage, community plugins, custom plugin. Dot use plugin. What? We can define the state for a plugin when we are calling use like this. Use the plugin and as global. Here, the name of the plugin and TypeScript expected one argument but got two. Use this. What is this taken? This takes in scope. No, this does not take in scope. Scope is defined within the plugin itself. Explain the plugin scopes. How are the different scopes for the plugins? Global, we do not need global. And also the hierarchy. Parent, child and everything. Yep. Scope level. There was a thing here which explained who is the parent, who is the child. Retry. Okay, I guess it is trying to make a drawing. Yes, drawing boundaries. Okay, cool. So that is some cool animation. Actually, if the scope is local, then the plugin defined somewhere slash plugin slash parent. Plugin runs on all routes to plugin and in parent. And if encapsulated, runs parent looks still falling into plugin, still flow, parent hooks still flow into plugin, local, okay, and parent app, define the child parent hierarchy structure. What are we calling a parent and what is a child? In Elysia, the hierarchy flows like this. Plugin hook defined here, hard wall. Okay, I didn't know this would make like animations like this. Attempting harmful actions. If we have a new Elysia instance and then root owns all state on which we define .use on it, plugin A, plugin B, plugin C, all are here. This is a child of A. Okay, the things. Can a plugin contain another plugin in A? I didn't call this. You have hit your limit for Claude message. Shades, 2:30 p.m. Okay, decorate and state were defined by plugin B, and it defines this needed route 1, route 2 by plugin B and plugin C. Global hook inheritance, root hooks and plugin hooks inherited from root and route handler seems C's merged hook chain, route 1, route 2, local state. Okay, the rules of Elysia hierarchy is new Elysia is always the root. It is the single owner of the final merged hook chain, root, route table, and type system. Everything else is mounted onto it via use. Plugins are children. Each plugin is itself just another new Elysia instance. There is no special plugin class where you use .plugin. Elysia merges the plugins, routes, state, decorators, and hooks into the parent according to the plugin's scope. Okay, according to the plugin's scope. And the scope is defined like this. If local scope, parent, and something defined by the plugin. If the thing is local, then it does not go to the parent. If it is, okay, we want the thing to go to the parent. We want the effects to go to the parent. We want the effects to go to the parent, but not to parent's parent. Okay. Share daily limits have been reached. Maybe if we change the model, haiku or AI arena is like free, pretty cool. Video comparisons, we can have videos. Phone is still not charged. Okay, this is for video direct. And okay, let's make a video, make a just like a side quest, make a 3 blue 1 brown type video which explains nihilism as presented by Nietzsche. Let's see, let bro cook, and while here max, or we could use anything that we want. Claude Sonnet 4.5. Okay, I'm using Elysia JS for backend. I want plugins to have effects on their immediate parent, but not their parent's parent, if that makes sense. Generating video. Cool. Scoping plugins in Elijah. In Elijah JS, you can control plugin scope using scope plugin. Yes, we are doing that. Okay, there are multiple methods to do this. Okay. Method 1, use scoped. Derive plugin data parent.use.scoped or scoped. What does this do? Wrap plugin with .scoped to limit its effect. And grand parent, it won't go to the grand, or use plugin as scope by default. Scope plugin is a function which we are calling, which returns an Elijah state set scoped in constructor. Scoped is true. Scoped is true. Scope true means only affects immediate parent. I mean, this is also cool. We could use a function which, because we would like to have a clone of a single plugin, we could have a wrapper function which returns the Elijah instance instead of cloning the same instance again and again. Or scoped, we can just say scope, and this thing would only apply to the immediate parent. Scoped is not there. Auth header as scope. This thing is as scope should only be applied to its immediate parent and not to anything else. The resolve part, and yep, we are not defining anything else, just the resolve. Here also it is scope, and here also it is scope, but the thing is the plugin is being applied to everything even. Okay, we have the video.
Nietzsche's nihilism began.
Nietzsche grappled deeply with the idea of nihilism, a term he used to describe the devaluation of the highest values.
Arena, AI Arena video.
Begins with the death of God, the collapse of absolute values. Eternal recurrence challenges us to live as if our choice.
Okay, it only created like a very short video. Okay, but I guess this one was better. This one was better. The one on the left. A is better. Cool. Let's go. It was by Grok. Okay, shit. And the one on the right was by LTX, which is something. Hugging Face library. Okay, cool. Scope plugin, scope level. Apply to parent, do not apply to main. Cool. And the way that we define it is like this, using as keyword. You are seeing testing token. pages login. Here we are calling this function, and internally login user, calling this console.log, sending a request to create account. Docker compose build nginx dev docker compose down nginx dev docker compose create nginx dev docker compose start nginx dev. Cool. When we create account, Wallace 154 request sent to backend, request sent to create account. Okay, we are sending the request to the right endpoint. Creating new user, we do not see this. Docker logs for backend, just this, and we do not see creating user. Why did we saw this thing twice? Backend is running port 2222. If we just remove everything except this, docker compose stop, control C, docker compose build backend, docker compose build create backend, docker compose start. Backend is working. We go to the login page. Why are we still sending .me request? Fine. Error. Okay, and docker logs backend, we didn't get the request, even though now we are in this APIs, we are just adding this use shit. Maybe no. we remove this also and apply access directly here as global. App backend index.ts error one.serve gave error probably because we messed up with APIs here. Cool. And if we do the same, now we are still getting error because something is running on port 2222. Something is already running there. Docker compose build backend docker compose down backend docker compose create compose up backend. Nothing. Okay. Full code not found. Cool. Anything here? Attaching to backend and send request to backend. Login user the function and request sent to backend. This is just the route. This is not sending the actual request. We are sending the actual request here. Await exhaust console.log. Response is res. Cool. Docker compose build Nginx dev docker down docker compose down Nginx dev docker compose create Nginx dev and docker compose start Nginx dev. That starts this. Response was this. We have data error true, message is Postgres error. Const no auth paths listening new leisure dot use access small n. Dot auth uses auth paths and anonymous key. Okay. Then why is the front end sending a request to /me route afterwards? Okay, this happens. We got the response, exhaust error, and user.data state. Okay, shit, this should not happen if there was an error. Yes, this should not happen if there was an error. Cool, makes sense. If res dot data dot error, then throw new error error logging in. It would be handled by this, which will wait, what will this do? This will return nil, and here if this was this, otherwise set error is I think an inbuilt function. Set error is this, which would just set the error here. Cool. The error is, the problem is we are not able to communicate with Postgres, which is much easier to solve now. And I guess the plugin issue was not even an issue. Cool. Docker, compose, build the whole thing again, everything, even Postgres. Now we have to make the Postgres, the local Postgres server and the backend server communicate with each other. Docker compose down, remove everything. Docker compose create containers. Docker compose start, and cool. The problem is in the backend. Backend cannot talk to the database, which is done by this, and which is, how does this get the database URL? Let's console.log database URL. Docker compose build just the backend. Docker compose down, bring down the backend. Docker compose up, backend server is this. Cool. Postgres, password Postgres. Cool, we should be able to connect to this. Let's try to connect using exec PSQL. How do we install PSQL using one? Can we install PSQL using one? Or does this image have hello build and run command? Okay, what, which one? a single command to build and run Docker container. Is apt here? Sure, apt is not here. Vim is not here. Nano is not here. Nothing is here. We do have the right thing, but we are not able to connect to this thing. Postgres using this database URL. Postgres colon. This part is telling the protocol, which is Postgres. This part is telling the username. This is the password. This is the host name, Postgres, which is the container name. And okay. Docker ps network status created networks. How do we see what networks are these part of? Docker compose up, remove orphan, force, recreate, build. Okay. Remove orphans, force, recreate, and also build. Remove orphan, and we can just say like backend. Okay, cool. That runs everything, and we are getting the logs for everything also. That is cool. 5432. This is listening on port 5432. Backend is also trying to go to port 5432. Okay. Listen on all addresses. Do we have the tables? Let's see. We can connect to this database PSQL help host is localhost and port is 5432. Host port database chess and also user Postgres. Password is password. Connection to server as is port. Failed database chess does not exist. Host localhost p 5432 Postgres. We are in dt. Okay, all of these are being built. Tables are being built, but not inside any specific database. They are just in the global space, which is fine, I think. Which is fine. They are not being built inside a specific database. They are inside the global space. Is it okay? Global space and not in database. Is it okay? software engineer stack, 14 years ago. Okay, very recent. Should we create a database structure with minimal number? And the answer is ignore the number of tables. Worry more about getting the design correct. If your major concern is quantity of tables, you should probably not design database systems. Okay, shit, bro, is very harsh. If your friend only needed 8 tables and the system works fine with that, then 8 is the correct number. Okay. But the question was about database. Should we create a database structure with minimum number of tables? I want to know a database should have exact, not the number of tables, but should we have a database at all? In scope applications, I am trying to do this. The message is only a recommendation, so it is possible to create custom tables in global scape. It depends on the use case, if it is best practice or not. Okay, what do you mean by my table is not showing as application scope in the left side filter panel for one? If we drop the concept of a database, we can be happy, probably. But we can create a database. There is no problem to create a database and create inside the tables inside that database. What are the benefits of creating tables inside a database instead of doing it in the global space? Because here I don't think it is like necessary. Key benefits: organization, it schema, multi-tenacity, whatever tenacity means, security and access control. All tables in one flat namespace, messy. At scale, cannot isolate permissions. Okay, let's create a database then. Database np SQL from a file SQL. You create database. Okay, not too complicated, I guess. We can just go to backend database SQL at the top. Yes, and then how to create tables inside a database in Postgres without going into the database. By giving in this command by giving in this command, but that would not work for us. Because we have a file which you want to run when the database starts up, when Postgres starts up, and entry point, how do we give this thing a database specific? Docker to create the initial tables. I want to create them inside database. How do we do that? Create them inside a database. Create database. If not exist my app, then slash. Okay, shit, we can give a command like this also. Okay, that is pretty cool. Apps backend database. Create database. This if not present is a command here. If not exist, if not exists, yes, and then see this the cool, and then do all of this inside chess. Cool. Okay, and Docker compose up, remove orphans, force recreate, and build. When we are using force recreate, why do we have to say build also? Docker compose help. These are the commands. Docker compose up, help. These are the commands. Build images before starting the containers. Okay, and force recreate containers if their configuration and image haven't changed, even if okay, recreate and string remove orphans, remove containers for services not defined in the compose file. Okay, cool, makes sense. Backend gave this okay, is the backend able to communicate with Postgres? Let's see. Bad request and got token, request received, headers got token. Network login response. Backend database API, we are calling access, create new user. front end, we are never printing the creating user message. Now sending a request was sent to backend, and then Axios console.log response. We did not log response. We did not log a response. Okay, which means the problem could have been with this. Yep, it was with this. The password has to be cool. Response was this: data Postgres error, fatal Postgres error. Postgres database just does not exist. Docker compose up, remove orphan, course, rebuild, build, shade, remove over phn. Docker compose up, remove orphan, course, rebuild, build, compose up, remove orphan, course, rebuild, build. Now it works. Cool. To make the process less painful, from where the database connection is working or not, or if the database is up and table created, you can add health check and depends on in the Docker compose file. Here I have a, yes, this is very painful. In backend I do have this Postgres, so Postgres is working, and also if I make a connection to this Postgres with password and dt to see the tables are also there. See, chess database chess does not exist, even though the tables were created. The tables are being created, the database does not exist. Exit, but the database should exist, because database setup.sql, we are doing this create database chess, if not exist chess, and then go into chess and then create these tables inside chess. So we see that the tables are being created. Why is the database not being created? Database system was shut down. Database system is and this happens. Docker file, yeah, we copy this setup.sql file from apps, like where we are, the current folder, to this entry point. Exit docker exec interactive TTY with Postgres sh we are putting this in a slash docker entry cat slash docker entry point. Read error is this is a directory init db. This is a directory ls docker entry point which has a file psql. Init script init.sql should be the name. I think maybe, but if the file was not being picked up, why are these table being created? I don't know. Let's see. Error, true, Postgres error, again the same error code 305, fatal, does the database exist, SQL. Go to chess does not exist. ls slash docker init.sql cat docker. We do have this whole file which has at the top create database chess. If not exists chess. PSQL password. The tables are being created, but the database is not being created. It is better to mount it on a Docker Compose, not at the build time. Remember, when you do it on Docker file, it is on the image, okay? But when you do it on the Compose, it is on the container, right? So, but I think this should not matter in this case. Like, it is fine in both the cases, whether if it is in on the image or on the container. Like if the database has some data inside the image or inside the container, like it is both fine. There is also this way to create a database if we given like an environment variable. Maybe that might also work. Docker Compose up. Shit, okay. or try to trigger automatic database creation. How to trigger automatic database creation. Yes, Docker Compose. This is what I'm doing. This is a directory, and inside you can trigger database creation and initialization by placing SQL script in this directory. The database engine, this or Postgres, will automatically run these scripts when the container is created and the scripts are being run. Is that should trigger automatic data when you use environment variables. But like, I should not be using environment variables here when there is script for that same thing. This thing, create database chess. This command is not running, and this is also not running, but the rest of these are running. So some magic stuff is happening. But right now the container which is running, it did took SQL, the environment variable, to create a database. Shit, I messed up the password, which is simply password. See, chess still does not exist. Wait, previous connection kept. Chess still does not exist. So the database is not getting created, but the tables are getting created. Database just does not exist. Password, okay. Authentication failure. I messed up the password. And yep, share this thing that is happening. Here in Docker file, when this is just copying this SQL script onto this initial place where Postgres will read this and run this. This Postgres will run, I think, when the container is created and not when it is inside image. So yep, this script only runs when a container is created. Okay. Why does it not create any table? It does not create database with the correct name. Does not create database at all. Volume. Right, using Docker Compose down v to stop containers and remove all attached volumes. Clear existing data volumes. The most common reason a Docker PSQL initialization script fails is to create a database is that the data volume already exists. Postgres only executes a script in this if the data directory / data is completely empty. It is completely empty. We are not using any volume. Verify script location. Script location is fine. We have seen that. File permission is also fine because the tables are getting created. Docker Postgres is only creating tables and not databases. I guess we need a volume. Maybe we need a volume for this. Yes, you are correct. This thing have limitations with database creation scripts in this cannot create the initial database because they run after the default database is created. The default database is created from this. Okay. Postgres value db, postgres db. Okay, so now when we are giving, we have to give postgres db, then this, okay, they run after the default database has been created. The default database is created from database env variable or default postgres user value. You are already connected to a database. When this script runs. Okay, solution: use postgres database environment, which is recommended. Okay, environment variables and volume. This is the correct database. Volumes, why are they saying volumes? Dot slash apps, put this there. Okay, cool, we can do this. Volumes instead of defining this. Okay, makes sense. We don't even have to use build image. We don't even have to define this inside the Docker file. I suspect the volume already exists. Clear them first. There is no volume. This is going to mount this file, setup file, onto this, which is cool. And do not create database here. Create schema. If not exist app, create schema. But okay, app dot this is how we define stuff. Image is this, no. Build container name will be postgres. Image, no. Remove image. Networks, ports, command, environment variable, and volumes, mount volume from dot slash apps slash backend database setup dot SQL. Mount this onto docker entry point setup dot SQL or init dot SQL. But I guess we should also name this init dot SQL. That would be cool. Rename this to init.sql. Okay, that should like actually work. This should actually work. We are mounting the volume, the initial file, and also do not create database and this dot this stuff like this in whole substitute table space with table space this dot. Do it. Cool. Docker compose up, that should work. Also, the command create database if not exist chess can be problematic or higher Postgres version. Okay. Naming of the script. Naming I think is also not the issue, because when I was storing this, even as setup.sql, the tables were getting created. The problem was just this: we cannot create database from inside the SQL file. And this app.users syntax is crazy. Okay, let's try to reach the close 234. Cool. Allow. Also inspect. Walrus. Okay, shit. This database still does not exist even when we are giving here postgres underscore database. Postgres database. Yes, the order maybe matters. Mount the volume later on after creating the database. Maybe. Even though these are key value pairs, maybe the order still matters. Because the order does matter when we are giving in build and the image name. If we give the image name before giving in the build variable, we get error. Docker tries to first fetch the image, then somehow plans to run the build later on after fetching the image. Cool. Password. Chess does not exist. Still, chess does not exist. Even though we are giving environment variable here. This is not creating database chess. But at least the backend is able to talk to anyone. Can you do dn inside the PSQL? Yes. dn plus public owner list of schemas. This makes sense. Database owner equals, you see, list of schemas. How do we see a list of databases and okay, why is 50% of the CPU being used? /l. Nope, this is not here. Retry. Though the tables are getting created. Maybe password db comes first and then this. It just does not work. Why is this lagging? Windows server. Docker is taking a lot of stuff. Okay, how am I still connected? Chess still does not exist. Postgres DB chess does not exist. Most common issues and fixes is exists related to the directory where you run docker compose up. Run docker compose config to confirm the volume is mounted. It is mounted as expected. A pre-existing is down up init script. Create schema if not exist. What does this line do? Create schema if not exist. Okay, there is a lag. There is a big lag. Yep. A schema is a collection of database objects like tables, triggers, stored procedures, etc. Schema is connected with a user which is known as the schema owner. The database may have one or more schemas. To create a schema is just create a table, create schema. Create schema name, authorization owner, and then go. Okay, they say that we need to have this create schema if not exist chess at the top. Create schema if not exists. Yes. Okay. Docker compose up. Remove everything. Rebuild from scratch. Okay, all the containers have been recreated. SQL. Okay. I think you are fine as you are working on the public schema. So like the global level schema, I guess. I think in that case, if I just remove this from the backend URL, we should be fine, because the backend is trying to communicate. The tables are getting created. The tables are getting created, which is cool. So I guess we just make the backend talk to those public schemas and not trying to get into the chess database, which does not exist. But the thing is, like, we should be able to create a database. Refresh. Walrus. Response. Data. User finding error. Okay, which is better? We are not getting a user finding error. What is user finding error? Get login. Okay, get login. Got token user finding error. What is user finding error? Backend is sending a error. Well, now the backend and the database are able to communicate, which is like pretty good. User finding error. So this is an error. And where is it being called? It is being called here. If users.length is not equal to 0, okay, select from users, all users, and this thing happens inside this verify user function, which verifies if a user exists or not with this username and this password. Okay, if the length is not equal to 1, we throw a user finding error, and so someone is calling this verify user function. And okay, who is calling this verify user function? APIs, access, create user. When creating user, we do database user dot create this username and password, which internally gets the hash insert user into users, which must have created a user. Create PSQL select all from users and nothing. Shade. Okay, cool. So we didn't run this line. PSQL gave us error. Maybe PSQL gave us error. This is inside trying with console.log. Trying to create user. And if this went cool, console.log user created. Cool. And if it isn't created, but we are not throwing this error, user not created error, we are throwing this error, verify user, which is being called here by /login. Wait, why is /login? Makes sense. We have to create an account, not log in to an account. Makes sense. Okay, account created. Cool. Shit. This works. This works. Let's go. This is working locally. And an anonymous account. To close 2034. Let's go. And also there is a like cool Easter egg. If you allow your location to be seen and go to the root, the place where you are at right now will be lit up. Play. Walrus 1, password 123. Again, not login. We have to create a user. Walrus 1. Okay, and we can start a game. Random rapid increment finding place, and game does start, which is pretty cool. Wait, where is here? It is cool. Let's play the whole thing. And cool. Shit. Okay, I'm happy. And now white player's chance. Let's do a checkmate. Black will checkmate white. So black needs to go there. White king can go there. So block, and black needs a help here. So this checkmate, and the winner is blank. You have to update the UI. UI does not look very beautiful, but cool. This is working locally. Pretty good. I guess we can make a commit. Yes, and backend like prints the whole game. And this was all running inside Docker container. So yes, very cool. Git status, git add modified Docker file, deleted setup, added init.sql, and helper. Wait, we added the helper folder. What is inside helper? Keep cat helper keys.json. It has keys. Keys are required for something. Helper. Inside helper, instead of helper, we will call this keys. And in the backend, not Zobrist, but here, not helper, but keys. In the root, yep, path, and the same path is used by everything. So we are cool. Docker image ls, Docker remove image, backend Nginx, Postgres, local one, UI, and Nginx dev, local and UI. Remove all images in Docker. Yep. Okay, all the images are like still here. Docker RMI. Wait, Docker, yes. Okay, Docker remove UI Nginx dev backend Postgres Docker image ls, Docker image remove backend Nginx dev and UI. Okay, now pretty cool. Now git add everything. Cool. Nope. Dot git ignore and dot docker ignore Docker compose works if we go to a random folder, programming cd stuff, mkdir test. Shit, test already exists. Git clone https://github.com/then raghav ch star. Okay, Docker compose build everything from this file. So I just cloned an empty or like a new repository, and now I'm trying to see if this will work locally using Docker Compose. Docker is building, Docker Compose is building, go run build. Okay, it is built. Docker Compose, create Docker Compose, start. Okay, and if we go refresh, okay, shit, let's go, create walrus, 1 2 3, shit, there is an error. Why failed to internal server error? Server running, server is running. And what is this? It is a JWT token. No, front end is getting the right URL. Front end is getting the right URL. Users is empty, and front end is getting the right URL. Internal server error. Is the server working? Docker exec interactive tty backend sh bun apps backend index dot ps. Now the server is running, even though it was supposed to be running already. Server is still, how is it still running? If we bun apps backend index.ts, okay, how are we able to start more servers, start multiple processes? How are like multiple processes listening at the same port 2222? There is no new in this. might be because of this. Docker compose up, remove, orphan, force, rebuild, and build. Orphans, recreate, not rebuild. What is the response saying on the Chrome debugging network tag? Okay, shit. Something broke shit, which is cool. And when we create account, walrus, and now I am in. Somehow now it is working. Shit. Got two users. Me. Okay. Because this is. If now I am in the different PWD. This is the place where I cloned the whole thing, and Docker compose up, remove, orphans, force, recreate, build. If you do this here, this might mess up. Backend is listening. Cool. Not login, but create a user. Error from create users / create user not created. User not created. That is a message sent by the backend. Okay. This is user not created. And it is being called by export database errors, user not created, bun, cannot find bun. It is this not running? Cannot find console. Did you mean to change the target library? Let's see, it might work now, or like we will see the what is being logged on the backend. User not created and creating user. Okay, we did go to this part. User not created. Okay, nothing is here because we didn't do one install tool user not created. Okay, so we are getting to this part. Console.log hash password, and then we are actually console.log calling psql works fine, and console.log called psql. Okay, that should be enough. Front end is building. Server is listening. Cool. Restart. We are on sign up. Why is this lagging? 80% of the RAM is being used. Docker is using 5 GB. Account not created and calling pql. Okay, we were not able to connect to pql. Why were we not able to connect psql? Either we did get the hash password. There the user was created. Okay, the user was created. The user was created. Okay, we did await. The user was created. So oh, why was this not printed? If we create another user now, walrus1, the same password, create user, and is in harpoon sql. Okay, now the new user was not created. Though psql is working, backend is not able to connect to psql. In here, before running this, let's say sql console.log. This thing is throwing error. Res equals this, console.log. Res or catch error. Console.log error Site cannot be reached, of course. Now it can be reached. Create a user, and just to make sure, select all from users. There is already a user, Walrus. How is there already a user there? Docker ps docker ps docker remove postgres docker compose create postgres docker compose start and SQL select all from users. Okay, now the user is gone. Cool. Internal server error, still crazy. Logs, okay. Docker compose down. Docker create start, okay, refresh, still internal. We had already fixed this internal server error problem, but okay, we will have to fix it again. We are getting the JWT which we are printing due to some reason, and it's like wait, SQL user is not there. Error. Okay, cool. That is like much better because we have something to work with. Creating user, calling PSQL, and this is the error. Connection refused. Connection refused. Node. Who is refusing local host? Local host. Docker compose, but why are we trying to connect to localhost? Shit, why? Wait, why is this localhost still? Here, this thing is Postgres, like at the rate Postgres. Okay, why is this localhost? This thing says localhost database URL equal to localhost, and here Docker compose. This thing is saying Postgres. And Git is saying that there is no other change here. Okay. Do we have to debug Git now? Hello. Monkey di Rufi. Kaizo ko ni Naruto ko da. shit. Git push origin main. Here, get the latest one. And get status. Shit, we messed up. We made some changes on in this aborting. Git diff. We added these lines. Git restore hard. Shit. Git reset hard. Git status. Git pull. And yep, docker compose up, rebuild, no, docker compose up, remove orphans, build, that should work. The problem was we updated the docker file, but we didn't push it, so we were not getting in this like clone folder the latest docker compose file, which we are getting now. And are we still getting that random user being created? No. Cool. Okay, user created successfully. Pretty cool. So now the state is that anyone can run this. Using Docker Compose, anyone can run this. Exit. I would run this in a virtual machine to just test whether anyone who has Docker can run this or not. But I do not have a virtual machine, my bad. But I do have a virtual machine. Shit. Yes, we can like set it up. Wait, this won't take long. Only installing the ISO will take long. Programming. Installing 700 MBs, just cool. So now anyone can run this. Now the next goal is to push this so that anyone who is not a developer can also run this. Cool. We have to set up a CI/CD pipeline, and before setting up a CI/CD pipeline, let's just set up a CI/CD pipeline. Okay, shit, the folder was quite big, I guess. Okay, CI/CD pipeline, and nothing much would. The most complex thing that is going to happen in the CI/CD pipeline is that we want to change the SSH port from 22 to something else, because on port 22 we want the TUI app, the Go TUI app to run. And also, wait, shit, is the Go TUI able to talk? Docker PS. Yes, Docker compose build. I guess the TUI is not able to talk. Docker compose create, and then Docker compose start. Okay, and Docker, yes, the TUI is running on port 242345 SSH, localhost on port 2345. Hmm. Yep, yep, yep. Remote host identification has changed. It is possible that someone is doing something nasty. Someone could be eavesdropping on you right now, man, in the middle. It is also possible that a host key has just been changed. The fingerprint for this key sent by the remote host is this. Please contact us. Add correct host key in this to get correct host key. Known hosts. RMRF. And this slash dot SSH known hosts. Okay, and now SSH to localhost port this. Yep, add this password, nothing. Cool. Rapid connection closed by remote host. Okay, yes. Okay, shit. TUI stopped working. TUI is not working. Okay, yes, here, shit. TUI exited. Why did the TUI exit? Also, Docker logs for backend. There was no connection request there. Okay, this has downloaded. Posty. Here. CD-ROM. Boot order D. Yep, and folders, documents, programming, VM slash SOS. There is no Gen2. Debian is there. Okay, cool. Gen2 image, yep. There is no Gen2 image. Cool. That is just starting up the VM. We will download Git in this and try to run the Docker compose file that we ran there. For this, we need to install Git. In this, Git and Docker. Install Docker on Debian. Using this. It has been 2 hours 47 minutes. But I don't think we need to do this because we did already check that Docker Compose is working from another folder. So stop this. Shit. Just stop this. Activity monitor. Cool. Here, now the problem is the TUI is not able to talk to the backend. And why is that? Status apps TUI is not able to communicate with the backend. Why is that? After we get this, let's print URL print line URL. Okay, Docker PS, everything is working. Docker compose build TUI. When we do Docker go build, why does it download all the dependencies? There is no caching in this. Okay, we have to fix that. Docker file, this is go mod tidy. This should install all the packages. Go install all go packages. How to fetch go mod init, go mod download, add download dependencies. You can explicitly download all dependencies listed in your go mod this. Okay, shit, go mod download. Alternatively, running go mod tidy will download missing packages and remove unused ones. But I guess it is fine. Cool. Now Docker compose, first of all remove TUI. Docker compose create TUI. Docker compose start TUI. TUI has started. Docker ps Docker logs for the TUI. TUI didn't print anything. Okay, I guess error. Yep, error. rm okay, Docker logs TUI. Cool. Well, shit, the URL is empty. URL is empty. URL is empty. And this should not have HTTP because we are trying to make a WebSocket connection, not an HTTP connection. Well, no. This thing back end URL. BACKEND URL. AWS. Yep. First of all, this has to be AWS. And why are we not getting this? Wait. Shade. Yes. We have to make change in this arguments. We are given arguments BACKEND URL is equal to localhost 2222 argument. Base backend URL equals backend URL okay. Backend URL is localhost go build. Okay. Dot slash. This would try to run on port 22. Yep. And error all. Okay. Shit. Address port 22 is already in use. Someone is using port 22 already. That is crazy. Run on port 23 port. Docker PS TUI is no longer running, which is cool. Docker, no, not Docker, but TUI.sh 1234 is already being used. So Docker remove TUI 1234. Okay, shit, yes, the front end is running that. Two, 3, 2, 5. TUI/SSH. Okay, it is running, but SSH localhost port 2325 2325. Yep. Error. Yep. So the environment variable is not reaching the go build command. Okay, how to get env variables to go. OS dot get env, that is how to get the variable, but how do we set load variables for local development? It is common to store variables in .env file, and nope, we want to give them when we run something like this goes to the env environment variable. If we have Good afternoon. If I run something like this, that should work. Then the backend URL env should be accessible by the main.go file, and should go into the binary Clarify this thing. Backend URL environment is available to go build process itself, but it does not automatically get embedded into the binary. Here is what actually happens when you do this. The environment go build command can read this during compilation if you explicitly use it in your process build, but the variable is not magically available to your binary at runtime. Why? What you need to do is to actually embed the value in your binary. You need to use build flags like this. Read at runtime. Shit, this read happens at a runtime. This read happens at runtime, so we have to give in this variable at runtime. We have to give in this variable at runtime. UI. Shit. Okay, I guess now we are happy. Docker compose build UI. Downloading, why is it downloading every time? We didn't even change anything, and this is downloading for go build. Go build should not download. And now docker rmi. Okay, shit, that was messed up. Docker compose build UI. We have to download build the image. Docker remove UI. There is no TUI. That is cool. Docker compose create TUI. Compose start TUI. TUI has started. Make the connection switch localhost port 2345. I think. Shit, that is not the port. Docker case A, the port for TUI is 2345. 2345 is the port. Identification required. Connection closed by SSH into localhost at port 2345. Shit. Yes. Yes, of course, because Docker compose build TUI. Docker compose down TUI. No, TUI is not working. Docker compose create TUI. Docker compose start TUI. sh now, yes, enter, cool, connection closed, docker logs for TUI, connection refused, and yep, the connection was at the right place this time. Cool, cool. And docker logs backend. Okay, it was just listening. And localhost 2222 slash game anonymous run. Connection was refused by the backend. Could be because of Nginx. But no, this is not because of Nginx. No, this is not because of Nginx, because the connection is going there. Yes, we are directly making the connection there using the localhost URL and not using Nginx. Anonymous game start. Here, on open console log. But even before this, anonymous game start plugin, this thing runs, which is scoped and uses error plugin. Console.log got request, cool, got request, docker compose build backend, or just like this, start everything, stop, docker compose up, remove orphans and remove orphans, force recreate build. Okay, this should work. Okay, we got the and backend didn't see anything. The TUI is not able to make a connection with the backend. Shit, I closed the wrong one. The TUI stopped. The TUI stopped. Docker exec interactive TTY for the TUI. TUI is working. Cool. Already mine. Okay. container stop. Yeah. Export backend URL equal to localhost 2222. Okay, and now go build. Okay, and then UI search. Mhm. Okay. Hmm. There are bugs. I'm now able to play a game with myself, which is messed up, but shit. So we are able to play the game when we are running the binary on the host computer, but no, of course, because the backend and the TY have to be connected by a network and not like as they are connected right now. Cool. Volumes, Postgres, nope. TY has to be part of a network. Networks, SHA, and backend URL is backend 2222 because that is the name of the container backend, and Docker compose up, remove orphans, force recreate, and build. How long? 3 hours. Connection refused because yes, we messed up with the cool. Not sure. Localhost B2345, and this is just running Docker Compose. We haven't even begun to set up the CI/CD pipeline. Cool. Cool. Shit. Okay. Okay. That is pretty cool. That is pretty cool. Now anyone can run this locally if they want to. If they want to. That is. Now we just have to set up CI/CD pipeline for this. Cool. Stop this. Stop everything. Docker. Yes. Yep. Remove all the containers and system DF. Yep. Disk storage or something. Cool. Okay. So Docker Compose actually finally works. Git add everything. Yes. Docker Compose for TUI. So yep, okay, Docker Compose works totally. Now we have to set up the CI/CD pipeline so that anything that we make goes, any change that we make here directly goes to this AP South, goes to this Amazon server. And essentially what we have to do is just have on one side we can have a Docker Compose file, and this is just what we have to set up here. But maybe we can make two Docker Compose files, one for this and the other. No. The setup, I think, I don't know. I think generally is that whenever you make a commit to GitHub, whenever you push some change onto GitHub from your local machine, like there is some change in your project into GitHub, GitHub will spawn a new computer on which whatever you define in this deploy.yaml file, whatever you define in this GitHub workflow, these are the things that will run on this remote server, which is separate from your local machine and separate from the server, from the Amazon AWS server. So yep, this thing will happen. And here I already have a older CI/CD pipeline in which whenever there is a push on the main branch, I have defined some jobs that should happen. One job is deploy the backend, and the name here is this is what you will see from outside, and this is a more descriptive thing, description about the job. And here we are defining what is what operating system should be running on this remote server, and then the steps in this job. Step number 1, name for this step is deploy via SSH, and this uses a GitHub action, and GitHub actions are pretty cool. GitHub actions are just steps defined by someone else. These are like functions you can call with arguments, and the arguments for this SSH GitHub action function are these. We have to give it the host, that is the URL for this AWS server into which we want to SSH action, the username, the key for SSH, the secret key, the port on which the SSH daemon is listening, and the script, that is when we have done SSH into the server, what should happen. And this should happen. We will go to SHA, which is like the place where the project is, and then we will run this bash file deploy.sh, and this deploy.sh is this scripts deploy.sh. This pulls the latest code. Backend, for backend it starts using pm2, restarts the backend, and for the TUI it goes into the TUI folder, rebuilds the whole thing, sudo setcap. This thing gives this process TUI.sh, this is a binary, access to port number 22, because this process .sh needs to run on port number 22, so it needs some special permissions to do that. Cool. Then deploy the TUI. what we need to do now is log into Docker, push the whole code, create the image, push the new image, and then SSH into the AWS machine and start the container. From those images. But okay, cool. Yeah. So we will take this first of all, and wait, but SSH with key being dot SSH. Key is in documents, VPS, secret walrus key, and this would work, I think. Yes, okay, this works. Now here we have to install Docker. Okay, what's CI/CD pipeline? I heard someone say that the CI/CD pipeline should be such that the developer never has to SSH into the remote AWS server ever, and everything is handled automatically. But how? But if that is the requirement, then the CI/CD pipeline, then the CI/CD has to confirm every time whether it is SSHing into the remote machine the first time or not, and if it is the first time, then install Docker and then pull the code and run. Or maybe not even. No, pull the image, pull the image, not the code. Pull the image and run. You're touching on a real tension here, okay? Then do it once. Model infrastructure as code. Okay. But the idea is that you should solve this problem once upfront, not on every CI/CD. Okay, the do it once model, infrastructure as code. Use tools like Terraform, CloudFormation, or Ansible. I have heard Ansible somewhere. Ansible provision the AWS server with everything pre-installed. Docker Compose, any runtime dependencies, SSH keys for CI/CD access. We would also like to, before we run our code, there are two things that we need. One is, or like just two things, Docker and SSH port from 22 to, let's say, 4321. Cool. These are the two things that I need to know need to do on the AWS server once, and then the CI/CD pipeline should work. And why does the SSH port needs to be changed from 22? Because on port 22, that uh, uh, go TY would be running on port 22. Infrastructure as code, IAC tools like this are used for this. CI/CD just deploys once the server exists. Your pipeline SSHs into the server. Okay, it is not CI/CD's thing to install the server. Why this works? Idempotent. First setup everything, and then every time CI/CD just deploys the code. Okay. So how do I set up? At the start, before CI/CD, I need two things: Docker installed and change the SSD port from 22 to 1234. How do we do that? Or how do, let's see, how do we do that? Exactly, these are infrastructure setup tasks that belong to your IAC, not CI/CD. Okay, this is like very new, very new. Linux forever. Yes, Linux forever. Hello, 2001 is your name. Maybe you were born in that year, 1000 year after Jesus. Here is how to do it with Terraform. Okay, shit. I had no idea that there are like multiple stuff like this. I thought CI/CD is the thing, but this is more complex. Not complex, but vast. Shit. Okay, there are CI/CD is to deploy your code. CI is for making formatting right and checking the formatting and running tests whenever you make a commit, and CD is for deploying the code. But there are other services called IAC, infrastructure as code, which set up your servers before the CI/CD thing runs, before CD runs. Okay, shit. Okay, and there is a tool called, what is this? Terraform main.tf. Shit, it has its own language, .tf lang. If it is a big enough language, it is not here. Ansible. Okay, Ansible is here. Ansible is a tool for this introduction. Ansible and is an orchestration tool written in Python. Ansible is one of the many orchestration tools. It allows you to control your environment, infrastructure, and code and automate the manual tasks. Ansible has great integration with multiple operating systems, even Windows and some hardware such as firewalls. It has multiple tools. Okay, so like whatever this new technology of orchestrating your server before running CI/CD is, there are two things that we want to run: Docker and SSH. Okay, Terraform. Okay, so what would be the best thing? Or wait, shit, I hope I don't get copyright when I run this. We can watch a Vercel video which explains this, like what is Ansible. That is the best place. Ansible, why should Ansible in 100 seconds, that is what we need. Terraform in 100 seconds. DevOps CI/CD in 100 seconds, that is like, yes, what we need exactly. And let me see if my audio is done.
Ansible, an open source automation tool that can describe your IT infrastructure with simple declarative code. It was created by Michael DeHaan in 2012, then acquired by Red Hat. Ansible, an open source automation tool that can describe your IT infrastructure with simple declarative code. It was created by Michael DeHaan in 2012, then acquired by Red Hat a few years later, and today is one of the most popular configuration management tools. Most importantly, it uses declarative push-based YAML code that allows DevOps teams to easily automate their Linux servers, increasing efficiency while reducing the likelihood of human error. It works by making at least one machine a control node. It then connects to multiple manage nodes and sends them an Ansible module over SSH, which can configure that machine's dependencies, update network settings, provision databases, or really any job that you might need to do more than once. Developers write playbooks that contain a series of jobs called plays. Each play is a set of instructions
Update web server hosts.
that can be
Write Apache config. Makes sense.
executed on one or more target hosts. It will execute each task in order against all machines in parallel. In addition, a playbook is idempotent, which means it won't actually make any changes unless it has to. An excellent real-world use case for Ansible is to manage your Linux servers on a platform like Linode. We start by provisioning a server running Ubuntu as the control node, then into it from the terminal. From there, we can install Ansible on this machine. This machine needs permission to create and modify other servers, so we'll get an access token for the Linode API and store it somewhere securely. Now, what's awesome about Ansible is that it has a massive ecosystem of pre-built playbooks that can be accessed on Ansible Galaxy. Install the collection for Linode using the Ansible Galaxy command. From there, it's a good practice to use Ansible Vault to store sensitive information like a password.
Okay. We can use Ansible for setting up the infrastructure for the actual code, or Terraform. Let's see. Terraform looks more modern. Let's see.
Terraform, an infrastructure as code tool that can provision resources in the cloud from simple declarative code. When building an app in the cloud, you may find yourself using the graphical user interface of your favorite cloud provider, clicking on buttons and paying for products just like you would on an e-commerce site. The only drawback of this approach is that it's complete and total chaos. You might click 1,000 different buttons to get your VM configured properly, but what happens when you need to reproduce the same thing again in the future? Terraform provides a way to build, change, and version infrastructure safely and efficiently by representing your infrastructure and all of its settings with the HashiCorp configuration language, or optionally JSON. Think of it like a human-readable blueprint that can execute and automate everything you do in the cloud. It's free and open source, and the first step to get started is to install the CLI on your local system. Then from your project, create a file ending in .tf. At the top, we have a Terraform block that controls global settings for Terraform itself. Most importantly, we can define providers here, which are like plugins that can connect to different cloud providers like AWS, Google Cloud, Azure, etc. Below that, we have a provider block, which gives Terraform the necessary credentials to connect to our Google Cloud account. From there, we can create actual cloud infrastructure using a resource block. It takes a type as its first argument, which corresponds to a product on Google Cloud, then a custom name to identify it as the second argument. Inside the block, we can customize the settings of the resource, like its machine type, zone, and anything else you can imagine. Now that our infrastructure is defined as code, we can run Terraform init to initialize the project, then Terraform apply to make the actual changes to Google Cloud. It'll require a confirmation before making the changes, then after it's complete, the Terraform show command can be used to inspect the current state of the infrastructure. What's awesome is that as we add more resources to the configuration, Terraform keeps track of the changes or diff, similar to a version control system like Git. Just run Terraform apply again to deploy any changes to the configuration. Now, once your startup has failed and it comes time to tear down the project, use the Terraform destroy command as the inverse of apply to delete everything in your configuration file. This has been infrastructure as code with Terraform in 100 seconds. Make sure to hit the like button.
Okay, cool. So we have to use Terraform, but I guess okay. I just have a simple Okay, how to use Terraform with AWS. AWS resource define app server AMI. This is for Ubuntu. Instance type, if the instance type is this, key pair, key name, user data, file, init script, modify assets mode. This script will install Docker, I guess. Terraform. Infrastructure as code. HashiCorp, written by HashiCorp. Documentation, install, intro to Terraform, tutorials. See, HashiCorp Terraform is an infrastructure as code tool that lets you define both cloud and on-prem resources in human readable configuration. Files that you can version, reuse, and share. You can then use a consistent workflow to provision and manage all your infrastructure throughout its lifecycle. Terraform can manage. How does Terraform work? Terraform creates and manages resources on cloud platforms and other services through their application programming interfaces. APIs providers and enable Terraform to work with virtually any platform or service with an accessible. Okay, the core workflow is like this, right? You define resources which may be accessible, which may be across multiple cloud providers and services. For example, you might create a configuration to deploy an application on virtual machine in a virtual, yes, that is what exactly our use case, network with security groups and a load balancer. We don't need a load balancer because we just have a single server. Yep, not much. Plan. Terraform creates an execution plan describing the infrastructure it will create, update, or destroy based on the existing infrastructure and your configuration. We write the configuration, Terraform creates the plan, and then Terraform applies the plan via Terraform. Okay, and then how to use Terraform, get started. Cool. Get started. Yes, AWS. We want to start with AWS. Create, manage, and destroy AWS infrastructure with Terraform step by step. Command line tutorial will walk you. Cool. Start. They also have a video, which is pretty cool. Let's watch the video.
Infrastructure as code tools such as Terraform allow you to manage infrastructure with configuration files rather than through a graphical user interface. Infrastructure as code allows you to build, change, and manage your infrastructure in a safe, consistent, and repeatable way by defining resource configurations that you can version, reuse, and share. Terraform is HashiCorp's infrastructure as code tool. It lets you define resources and infrastructure in human-readable, declarative configuration files, and manages your infrastructure's lifecycle. Using Terraform has several advantages over manually managing your infrastructure. Terraform can manage infrastructure on multiple cloud platforms. The human-readable configuration language helps you write infrastructure as code quickly. Terraform State allows you to track resource changes throughout your deployments. Remote backends, such as Terraform Cloud, allow your team to version control your configuration and collaborate on infrastructure. Terraform plugins called providers let Terraform interact with cloud platforms and other services via their application programming interfaces, or APIs. HashiCorp and the Terraform community have written over 1,000 providers to manage resources on AWS, Azure, GCP, Kubernetes, just to name a few. Find providers for many of the platforms and services you already use in the Terraform registry. Providers define individual units of infrastructure, for example, compute instances or private networks, as resources. You can combine resources from different providers into reusable Terraform configurations called modules, and manage them with a consistent language and workflow. Terraform's configuration language is declarative, meaning that it describes the desired end state of your infrastructure, in contrast to procedural programming languages that require step-by-step instructions to perform tasks. Terraform providers automatically calculate dependencies between resources to create or destroy them in the correct order. To deploy infrastructure with Terraform, first, define your scope. Identify the infrastructure to be used by your project. Second, author. Write the configuration for your infrastructure. Third, initialize. Install the plugins Terraform needs to manage your infrastructure. Fourth, plan. Preview the changes Terraform will make to match your configuration. And finally, apply to make the planned changes. Terraform keeps track of your real infrastructure in a state file, which acts as a source of truth for your environment. Terraform uses the state file to determine what changes to make to your infrastructure so that it will match your configuration. Terraform allows you to collaborate on your infrastructure with its remote state backend feature. When you use Terraform Cloud, you can securely share your state with your teammates, provide a stable environment for Terraform to run in, and prevent race conditions when multiple people make configuration changes at once. You can also connect Terraform Cloud to version control systems like GitHub, GitLab, and others, allowing it to automatically propose infrastructure changes when you commit configuration changes to VCS. This lets you manage changes to your infrastructure like changes to code with version control. Now that you are familiar with the core concepts of infrastructure as code with Terraform,
Okay, kind of familiar. Manage infrastructure. Cool. Next is the next install Terraform. Cool. Linux forever install Terraform. Shit. Nix exit cd dot n dot. I think I should add alias dot alias for Nix words. Alias Nix d to download something equals nvim config nix leak dot nixd. Crazy shit. Config nix leak dot nix. Cool. Terraform is it. Darwin rebuild switch and plague slash dot config nix slash dot walrus the username password we are doing this to shit install Terraform show trace. Okay, there is some problem with Terraform. While calling this username attribute located at this generic, is this because of Terraform? To temporarily allow unfree license, allow unfree equal to 1 when using Nix install. Okay, what are unfree things? Nix was unfree. What does unfree mean? Per package ideal, this method works. In Nix config, we can say unfree equal to true, but what are unfree packages? I cannot install unfree packages and this. Okay. Can you share what command? Software packages in Nix package repository that have a restrictive license regarding distribution or modification, such as proprietary software, example VS Code, Discord. Okay. Here we have to say just unfree equal to true setting and free equal to config. Okay, and this should work. It still does not work. Oh, shit. Allow unfree equal to true, not unfree equal to true. Okay. Unfree capital. Okay. It is downloading, and I'll be like right back. I will wash my face and come back. It has been 3 hours. I would like to wash my face. I'll be right back in 1 minute. It is still downloading. Linux forever. Wait, there is an update. Brave just is not working. Brave is here. Data eraser while this is downloading. Build. Wait, shit. This is building the whole thing. Build phase. Why is Terraform being built? Okay, fine. Message. 72, not too good. Terraform is downloading. Let's see some documentation. Install tutorial getting started. With AWS, yes, that is what we want. Install Terraform. We are installing Terraform, and they have a whole video about installing
HashiCorp
Terraform.
distributes Terraform as an executable CLI that you can install on supported operating systems, including macOS, Microsoft Windows, and several Linux distributions. If you use a package manager to install software on your macOS, Windows, or Linux system, you can use it to install Terraform. You can also install the Terraform executable manually or compile it from source. To install Terraform on your local machine, follow the instructions in the tutorial below. For macOS systems, you can use Homebrew, a free and open source package management system.
This video is just about how to install Terraform. That is crazy. That is terrible. Brew app, HashiCorp app, and then install. Cool. Okay. We can move on to the next one. How to create something in Terraform. Prerequisites: Terraform CLI, AWS CLI. We would need AWS CLI. We do have an AWS account, but we do not have AWS CLI. We need AWS CLI on AWS CLI. We would have to use AWS CLI Nginx OS for this too. And shit, hopefully, yes, the stream is still going. My internet is still connected. Cool. Okay, building subpack. Why is this building? Yesterday was bad enough as it was in building stuff. Next. Provide next package builds Terraform to provide a declarative and reproducible way to manage. No, not like Terraform package. Next package builds the Terraform package to provide a declarative and reproducible way to manage shit. I am using Nginx manager. My bad. Download Terraform, but it is building Terraform from source. Why? And this is taking GPU. Yes, this is taking quite a bit of CPU. All of the like normal cores are gone just for this. Flake.log binary cache miss. Nginx is likely building Terraform from source because binary cache miss. Nginx tries to fetch pre-built binaries from configured binary caches like cache.nginxos.org if your system configuration does not match a cache build or the I think this is building from scratch because no one installs Terraform using Nginx OS on Mac, using Nginx package manager on Mac. That could be it. Custom overrides if you there is no custom stuff. Unstable custom channel if you are not I'm using the main one. Architecture CF. Also because the operating system is not just macOS, it is more specifically macOS Tau. macOS Tau. So that makes sense. Nix Flakes. Sure. Good. That is why it is being built. Now, how can I push my build binary so that anyone else doing the same thing doesn't have to build it from scratch and can use my build binary. How do we do that? You need to set up a binary cache that Nginx can fetch from. Can I not just upload it somewhere? Cache easiest and recommended is the hosted binary cache service designed exactly for this. Okay, create a free trial tier available or paid for more storage. Okay, this gives you auth token and cache URL. Then next build first, next build, and then cache push my Terraform cache push into this thing. Others can use it by cachexx run cachexx use this. Okay, then anyone can add your cache to their config like this, or I won't be self-hosting. S3 bucket, GitHub actions plus this CI/CD approach, automated binary pushes. Nah, it is fine. It is fine. We don't have to save the word. We will just build it for ourselves. And we also need Amazon's CLI to make this work, but we cannot install it as long as we don't have this working. First, this has to build. More cores to Nginx to build stuff. How to give all the codes? Codes equal to 0. So a number of codes allowed per build. What is the default? Zero means all logical cores. Okay, what is the default? And tells next to build multiple packages at the same time. It max jobs cores tells next to allow each. Yeah, I guess 0 is the default, so it is using as many cores as it can use. Temporary CLI configuration. Yeah, fine. Yeah.
Use Terraform to create and manage your infrastructure as code. To begin a new infrastructure project with Terraform, you will write configuration to define your infrastructure, initialize your Terraform workspace, set your cloud provider credentials, and then use the Terraform CLI to create your infrastructure. In this video, we will create a single virtual machine with Terraform. When you start a new Terraform project, create a new directory on your local machine to store your Terraform workspace. Terraform commands work with the files in your current working directory. Change into your Terraform workspace's directory to create your configuration and run Terraform commands. Terraform configuration is written in plain text using HashiCorp's configuration language, HCL, with file names ending with .tf. Terraform configuration is made up of blocks that define each component of your infrastructure. The Terraform block configures Terraform itself, including which providers to install and which version of Terraform to use to provision your infrastructure. Terraform uses binary plugins called providers to manage your resources by calling your cloud provider's APIs. HashiCorp maintains the Terraform registry, where you can source public Terraform providers and modules. You can find the provider for your cloud vendor in the registry, as well as the documentation to use it. The required providers block specifies which providers Terraform will use to provision your infrastructure. Set version constraints on your provider to ensure consistent operations by avoiding major version upgrades during normal operations. Also, configure the version of Terraform itself in your Terraform block. When you write a new configuration, we recommend that you configure your provider and Terraform version in the Terraform block in terraform.tf, and then configure your provider and other resources in main.tf. Each provider block configures the corresponding provider. Here, you can set your cloud provider's region and other options that apply to the provider itself. You can use data sources to query your cloud provider for more information about other resources. Data sources help you keep your configuration dynamic and avoid hard-coded values. This data source loads an AMI for the most recent Ubuntu Noble Numbat release in the configured region. A resource block defines components of your infrastructure.
Building. Terraform is building. Then we would also need, okay, setting up groups and users. Almost done. Also, Terraform and AWS. How to get AWS CLI, CD, okay, toolkit. AWS CLI. I think this is it. This is it. And this would also be built probably. This would also be built probably. Getting the Darwin configuration. And this will take significantly longer to build, 231.4 MBs. If this is built, but I guess not. No, shit, it is not building because we are installing this from cache. It is building. Something, not the main thing. Cool. And also we would like to have resetter support for this. Resetter neural for Terraform. The name is Terraform. Terraform, and whenever we enter into a file name or anything .tf, that would mean Terraform. If we start new vim, that will download Terraform resetter, and we would also like to have an LSP if there is an LSP. LSP config all Terraform. Okay, shit. There's something for Terraform. Terraform LSP. Let's go. How to install this? Terraform LSP. Installation page. Shit, brew install or Nginx. We would have to do this using Nginx. Oh, cool. We do have Terraform LSP. But might build the whole thing again. Vim LSP enable this. Cool. We do have the LSP and everything. Cool. Cool. Stuff. Okay, we are inside and main.ts. We do get LSP support. Okay, okay. What did bro write in his main file?
Use Terraform to read Terraform with uses binary.
Unexpected keyword Terraform. That is very easy. I guess the name of the file has to be Terraform. TERRAFORM. TypeScript. Why is... Oh shit, my bad. LSP is not working. LSP enabled. No client with this name. Oh yeah, shit. But Terraform LSP is not giving any error. Okay. Inspect tree. No tree setter support. Right, let's write the Terraform stuff. Require providers. AWS. Do we have Terraform? We do have Terraform. Write the configuration. Terraform configuration files are plain text files in HashiCorp configuration language HCL with file names ending in .tf. When you perform some operations with the Terraform CLI, Terraform loads all the configuration files in the current working directory and automatically resolves dependencies. Terraform loads up all the configuration files in the current working directory like Docker and automatically resolves dependencies within configuration. This allows you to organize your code into multiple files and in any order you choose. Terraform configuration is organized into a few steps. Terraform block. The Terraform block configures Terraform itself, including which providers to install and which version of Terraform to use. Okay, which providers and versions of Terraform to use. Using a consistent file structure makes maintaining your Terraform projects easier, so we recommend configuring your Terraform block in dedicated terraform.tf file. Okay. Create and open a Terraform file and there enter the AWS thing, like what provider we need and the version for Terraform. Okay. HashiCorp Terraform providers. Terraform, AWS provider. We'll see something here. Okay. Configuration for Terraform. Use source this version. I guess we don't have to think too much about the version. It is fine. Provider AWS region. Okay, region is AP South, Asia Pacific South. Create a VPC, virtual private cloud, AWS VPC example. But Terraform version, what is the 1.4? So this one later. Okay. Provider does not exist. Okay, at least we are getting LSP support now, which is pretty cool. Terraform LSP is working. Provider does AWS does not exist. I guess we have to install the provider. Let's see. Here, do this. In it, prepare your working directory for other commands. Validate, plan, apply, destroy main commands. Okay. It is installing AWS, I guess. Yep. So our LSP won't be giving us error for AWS. Hopefully. Darwin AMD configure blocks. Okay, and then configure AWS itself. AP South. Give the version like that. AP South 1. It is still installing. Installing means building. Good. Successfully been initialized. You may now begin working on with Terraform. Try running Terraform plan to see any changes that are required for your infrastructure. All Terraform commands should now work. If you ever wait, now we are no longer getting error for AWS. Pretty cool. AWS not found. Cool. If you ever set or change modules or backend configuration for Terraform, rerun this command to reinstall. Okay. Configure the AWS provider. AP South. AP South 1. And creating a VPC. Okay. We have selected that we want to do something with AWS, and this is the reason where we want to do that thing. AP South configuration block. In this, use your text editor to paste Neovim, the best one out there. Filter AWS AMI Ubuntu. What is this saying? When you write new Terraform configuration, we recommend defining our provider blocks and other in some other file. As you add to your configuration, you may choose to organize. Okay, providers. The provider block configures options that apply to all resources managed by your provider, such as the region. To read them in this provider block configures AWS to use this region. Okay, note if you want rather in different data. Yep, okay, cool. You can use multiple provider blocks in your Terraform. Okay, configuration. To configure multiple providers or multiple instances of the same provider with different configurations, such as different region. Terraform providers must authenticate with your cloud provider's API to manage your resources. Providers often support multiple authentication methods. Terraform's AWS provider uses the same authentication method as AWS CLI. If you do not have already done, configure your AWS credentials as environment variables in your terminal. That is very risky. AWS access key. I guess. Okay. Let's. How do we run AWS CLI? Shit, 6 people watching. No. Just AWS. Okay, AWS version. But this does not work. Download AWS CLI mix packages. The name is AWS CLI 2. /config nix flake.nix AWS CLI. Oh shit, okay. And sudo Darwin rebuild switch /config nix flake dot just give the directory and the username was shit. Yes, because this has to be taught. Unknown option. Yes, because we also have to say flake, that this is the address for the flake. Cool. Git tree is dirty. AWS CLI is being downloaded. Cool. 7 people watching. Okay. And how long has it been? 4 hours. Okay, this will get us the CLI tooling or using AWS with Terraform. We need the AWS access key and secret access key, and then use the AWS CLI to verify your credentials. Okay, and then data sources. You can use data blocks like this data block to query your cloud provider for information about other resources. This data source fetches data about the latest AWS AMI. What is AMI? An Amazon machine image, a temporary blueprint used to launch virtual servers EC2 in AWS, like a Docker image, Amazon machine image containing the operating system, application server, and software configuration. It acts as a pre-configured image for quick deployment. Okay. Latest AMI, AWS AMI Ubuntu. We want to get information. Most recent, yes, about the most recent one, where the name is name and value is this, owner is this, canonical. Right. This data source fetches data about, we do have AWS. Cool, we do have AWS installed. Why is it taking like so long to tell its version? AWS help without the hyphen. Okay, the AWS command line interface option command. We don't need an option command. What are the what are the command global options, and there are no global commands. AWS configure list. Okay, I have to set this, and I will have to hide my screen for this. Log into AWS CLI. AWS login. AWS configure set region to new region. Okay, we will change the region later on. Walrus. If this shows something crazy, I will just hide this. Shit. Oh. Is this something bad? You have seen this already. Someone sees this, is this bad? Not immediately catastrophic, but yes, you should treat this as a security incident and take action now. Shade AWS account ID. This is semi-public information needed for ARN, semi-public temporary credential evidence. The OAuth shows someone or you authenticated to this. Okay. And device information, the callback URL. This happened on a local machine. Why this matters? If this appeared in a git commit, log file, or screenshot you shared, an attacker could probe your AWS account for resources like this. Attempt to assume roles. Okay, so you have seen my AWS account ID, but what to do right now? Check your AWS activity within 15 minutes. If possible, go to AWS console, check it. Rotate credentials immediately. If you are using root credentials, bad practice. Create a new IAM user with MFA and use that instead. Revoke any exposed access keys in IAM. I guess that is enough. I would like to take a rest, 4 hours, 20 minutes, and maybe I'll do another stream today, or even because I want to publish or complete this thing today. So yeah, I might do another stream. And in the meantime, if you can hack me, then I guess you should hack me. If this is like, this URL is not problematic, this might be problematic, but okay, that would be it. What we did, we have set up Docker Compose so that anyone can run this thing locally, which is pretty cool. And now we are learning how to use Terraform, because using Terraform, we do not have to define our virtual machine every time whenever we are setting it up. So that is pretty cool. The two things that we need Terraform for is to install Docker in the virtual machine and change the SSH port from 22 to 432. So pretty good. And that is what, for this same thing, we are using Terraform. Good. And yeah, that would be it. That would be it for today. And thanks for being here.